Is everybody ready?
Yeah.
Okay. I'm ready. Calculator here. Well, I've almost got my voice back, and I think I'm losing faith in modern medicine.
Mm,
All right, so we start with number 3. Did anybody read it already?
no.
Okay, I'll go till I can't talk. Find the margin of error for a 90% confidence interval when the standard deviation sigma 50 and sample size n equals 25, round to 3 decimal places. Okay, so the whole clue to this lesson seems to be using those 3 numbers for the 90, 95, and 99%. The Z critical, the Z score. So this is 90. We use the 1.645. And we do the little formula. I got 10.645, but I might be crazy. I don't know. See what everybody else got.
I got 16.45.
So I got, oh, I left out a 1. I put 0.645 instead of 1.645. Okay. So the answer is 16 point what?
45.
Okay. Yeah, I just made an error in my computing there, but.
Yeah, don't worry. Don't worry.
You want 3 decimal places though. Did you round up?
Yeah, I did. 16.450.
Okay. All right. Number 4. Which of the following statements is true? It's either the second one or the third one. I think it's the second one.
Yeah, it's the second one.
Because one, the sample is known and the mu is the population, it's unknown. We're trying to estimate it.
Mm-hmm.
Okay, that's what I got. So next one is word problems. Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation sigma is 113. She collects a random sample of n equals 64 and computes x bar or the sample mean to be 526. Use this information to answer the next 6 questions. What is the point estimate for the true GMAT score? And based on the question right before this, I put 526.
Yeah. Yeah. Okay. What is the margin of error for the 95% confidence interval for the true GMAT score?
I got 14.665. I'm not sure,
Yeah.
I'm not confident. What did you get?
I'm still working on it.
Okay. It's like the 1.96 times 113 over 8.
I got 27.685.
I got 27.685 when I redid it here. So
Yeah.
So how did you guys get that? I'm not getting that.
use that number, the Z critical for 95%, which is 1.96,
Mm-hmm.
and you multiply that times the sigma over the square root of the sample.
Okay.
I don't, maybe I got a sticky 1 or something on this calculator because I had a good understanding of this, but I'm getting wonky answers.
Oh yeah. I
One
got
up,
27.685. So yeah,
yeah, I got
perfect.
hey.
7. What is the lower limit of this confidence interval?
Okay, so it's going to be 526 minus 27.685.
Yeah.
Which is 498.315.
I just threw my calculator on the ground. Hold on.
No worries, we can wait.
I'm back.
Hello.
Let me subtract again.
Good. How are you?
Good. Oh, the weather's so lovely. It's so warm.
Okay, and then the second one is 526 plus.
I got 553.685.
Yeah, that's what I got. And then 9. What would happen to the width of the confidence interval if Gina increased the sample size? It would decrease, right?
That's what I put.
Wouldn't it increase? Oh, right, yeah.
Yeah, because then for question 10, it would increase because she's changing it to a 99% confidence interval, right? Or do I have them backwards?
That
No.
confused me too. I think it's decreased also because they're counting an increased confidence into a smaller confidence interval, so they're calling it decreasing because I missed that on the homework too, number 12. What's your take on it there, Lindsay?
No,
Don't
I
let the dog in.
just put it back down.
Come on.
I'm actually not sure on that one.
Yeah, it would decrease.
Yeah, it would increase, right? Number 10.
Oh, yeah.
So then 9 decrease and 10 increase.
Yeah.
All agreed? No? Yes? What about you, Debbie?
Well, on the homework, it says on number 12, the margin of error gets smaller as the level of confidence grows smaller. Okay, but they're not asking that.
No, they're asking the sample size.
Oh, the samples.
Wait, are we on question 11?
No, 10.
Oh,
Kind of discussing it. On the on the practice homework, it asks, how does the margin of error for 95%, blah, blah, blah. Then the answer was, the margin of error gets smaller as the level of confidence grows smaller. But it's not talking about like your belief or confidence. It's talking about the actual size of the parts. It's shaded like on the applet. So more confident would be smaller? I don't know. Well, we'll just see it. Let's just put it at,
yeah. Or we can do like one of us puts something and then the other one, and we'll see who gets it right.
yeah. So 10, we're gonna, consensus is increase, but we could put little question marks on here. Okay, go on to number 11. Light bulb company is studying to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval and a margin of error of 50 hours. What is the sample size they need? And it says round up. So I put number 11.
46.
246.
Yeah.
Yeah. Right. 12. The mean salary of actuaries is U equals 100,000 and the standard deviation is 36,730. You're interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with level of significance 0.05, and the whole is mean equals 100,000, and the dozen equals 100,000. You collect a simple random sample of n equals 36 women's salaries and find that x equals 111,000. Oh gosh, I don't know how to read numbers. What is the lower limit of this 95% confidence interval? Okay. So since it's 95, we're using the, what was it?
1.9.
1.96, right?
Yeah.
Okay.
And
I don't think I'm doing this right. I got 100,002. Well, 0.01, but instead to round.
Let's see what I got. I didn't work this one in advance. I ran out of time.
Okay, so process. I guess I'll wait to see what you guys get.
I got 99002.
What did you get, Debbie?
I'm trying it again because
How did you do number 12, Lindsay?
So I did the 36,730
Mm-hmm.
divided by the square root of 36,
Mm-hmm.
and then multiplied it by the 1.96. And then I took the x bar, 111,000, and subtracted the what I got for the.
Yeah.
yeah, the margin is plus or minus 11,998.
Yeah, that's what I got.
So the question is actually, what is the lower limit? So we take 111,000 and subtract this 11,998.466.
Yeah. Okay, so for 13, I got 122,998.
Yeah, I got that too.
Okay. No?
Are we supposed to? It says round to the nearest whole number, so would be
Whole number.
to the next number.
No, I think it just means like decimal places, wouldn't it?
Well, the
Yeah.
sigma is 336,730. They didn't put any decimal places on
Oh
it.
yeah, that's true.
Oh man,
I
I
don't
can
know.
do it without.
I think I'm just gonna leave them like that and see. You guys can round them.
Wait, hold on. 111.
Because then it would be 123, right? 000.
Oh. No. I don't know. I'm just gonna leave it too.
Yeah, I'm just gonna leave it because then I don't know to what we should round it. Okay,
Yeah.
for 14, there are 3 requirements that need to be checked when computing a confidence interval for a mean. They are: a simple random sample was drawn from the population, sigma is known, the X bar is normally distributed, all of the above. It's all of the above.
So yeah.
Okay, perfect. Ugh, I'm nervous. I gotta admit that I'm nervous. Oh, guess what? We got 100.
Yay.
Okay. Number 10 was increased. Good. All right.
For the what's it called, for the project, I was thinking about David's idea, and I think it's a good idea. And I also like thought about this idea, so that you guys can like think about it, or maybe like find more ideas. That we can like go to the store, and that way we don't have to like buy the product, and just like look at, since like for the most part we're like in different places, we can look at the different the different prices of milk, and compute like that data, like how much like it varies from like place to place. I don't know, just, and we could, and since there's like different brands of milk, like we could, you know, get like a lot of numbers.
Another idea I came up with was, you know how they have a sack of potatoes that says 5 pounds?
Yeah.
And then, but you could like get a couple of them and just weigh them there at the store on the scales and see how much it differs from 5 pounds.
Oh yeah, that's a good one too. All right, let's keep thinking about it. And yeah,